Okay, so this is another statics problem, and what we've got is a ladder, and the ladder is placed like this against the wall. This distance, say, is 3.5 meters, and this distance, say, is 5 meters. So we know the length of the ladder. Now, we also have a fireman climbing the ladder. So the fireman's going to be somewhere around here, let's say. And there is the weight of the fireman, and there's also the weight of the ladder. Okay? So what we'd like to do is draw the force vectors in a different color. Let's do that red. So there's two forces from the ground, and we'll say this is point G. So there's FGY. There's another force here called FGX. And there's another force here called the force of the wall. Now, realize that when a ladder is leaned up against a wall, there cannot be any horizontal forces here, because usually at this point right here there is a roller, okay? And at the bottom of the ladder there's usually a kind of looks like this, right? At the bottom of a ladder you have something that looks like this, and then at the top of the ladder looks like that. So there's a roller at the top, but at the bottom there's actually something that has teeth on it so that it doesn't slip. Now, we also have the weight of the ladder here. Mass of the ladder times G. And of course we also have the mass of the person times G. The question now is, how high up the ladder can the person go without the ladder slipping? Didn't do that right. Without the ladder slipping. So this can be considered that we really want to find either the distance along the ladder up or the distance basically vertically up. Now we still need some information we don't have. Number one, what is the mass of the person? And we'll say that the mass of the person is equal to 66 kilos. And also, we also need the mass of the ladder, and we'll say that's 10 kilos. Okay? We also need one more piece of information, and that is here at the ground, the coefficient of friction is going to be 0.45. Okay, that's static, not kinetic. Therefore, knowing all this information, now we can answer the question. What we need to do now is we need to once again start out with our equations. Summation of the forces in the x direction must equal 0. Let's start with that one. It should be pretty clear that the only two horizontal forces are FGX and FW. So I can say FGX minus FW has got to equal 0, or I can say FGX is going to equal FW. Now that's done. Now let's do summation of the forces in the y direction equals 0. So now I've got FGY minus MLG minus MPG, person and ladder, and those must also equal 0. Therefore, I can say that FGY must equal ML plus MP times G. And since I know what MP is and I know what ML is, I definitely know what FGY is going to be. Okay? Now, there's one more equation which we can use, summation of the torques. Now we have to decide upon what point we are going to take the summation of the torques about. Personally, it would probably be easiest, I think, to take the summation of the torques about this point here at the ground. So let's do that, because the reason why I say that is that if we pick this point G, out of the 1, 2, 3, 4, 5 forces, we're getting rid of 2 of them. Okay, so that's why I'm going to pick G. So let's make this a G, and we'll say that's equal to 0. Now, what we need to do is say, okay, that means we're left with 1, 2, 3 forces that create torque about point G. This mg and this mg both create a clockwise rotation, right? That is going to produce a negative torque. Clockwise is negative. And finally, Fw is going to produce a counterclockwise torque, which is positive. So let's do Fw first. Fw times, now what's the distance? Remember, we can draw a line through Fw and move it along that line of action such that to a location where it's acting here, it would be perpendicular to the arm from G to the point of where it acts. So we can basically move Fw right there, and therefore the distance is 5 meters. So let's put down 5 meters here. And that's positive, by the way, because it's counterclockwise about point G. Then let's do the other two. These two are both going to be negative. Now, what's this distance here? Because I'm going to move MLG right down to here. This distance here is now going to be half of 3.5. Why? Because the center of gravity of the ladder is right in the middle of the ladder, and if it's right in the middle of that ladder, that's also going to bisect this leg of the triangle. So half of 3.5. So that's going to be negative MLG times 3.5 by 2 meters. Okay? Now, we're also going to have negative, again, for this one here, MPG, except this is a distance that we do not know. And I'm going to make this in a different color here. So this distance here, right there, is where we can act MPG. This distance, I'm going to say, is an unknown value of x. Okay? And so, therefore, it's going to produce, again, a negative torque because it is clockwise. And I hope you understand why I'm saying it's clockwise. About point G here, this force is going to produce a clockwise rotation. And so, therefore, that's the reason for my negative. Okay? So, let's go MPG multiplied by x. And, of course, this all equals 0 because there's only 3 forces left, right? 1, 2, 3. So let's go ahead and see if we can figure out what x is. However, before we continue, we'll notice here that in this equation there is another unknown, and that's Fw. But we do know from before that Fw is equal to Fgx. Question: what is the relationship between Fgx and Fgy? Well, if you look at this relationship here, Fgx can be considered to be the normal force at point G. Sorry, let me say that again. Fgy can be considered to be the normal force, this guy, and Fgx can be considered to be the force of friction. Therefore, if you say force of friction equals mu Fn, normal force. Now, by the way, this equation only works for maximum conditions. Okay? Only for max situation. But, fortunately, this question is asking us for the maximum situation because it's asking us how high up the ladder can the person go without the ladder slipping. So at that point, at the maximum point this person is up on the ladder, it is on the verge of slipping. So therefore we're at a maximum condition. So this is going to be true. It's good. Now, we can replace this normal force with Fgy and the force of friction with Fgx. Now, we know what Fgy is. We've already figured that out here. So we can do some substitutions now. We can actually put Fgx is equal to mu times Fgy, and from up here, okay, I'm going to put that into there, ml plus mp times g. That's Fgy. And now I know what Fgx is. But if you'll notice, I also know that Fgx is equal to Fw. So therefore, this is going to equal Fw. Well, guess what? I now can put this equation, substitute it into there for Fw. So let's rewrite this equation again. But this time, let's replace Fw with this. Should have had the G in there. Okay, so we're going to go mu ml plus mp times G times a 5 minus mlg 3.5 by 2, that's meters, minus mpg times x equals 0. And you can see now that basically my only unknown in this equation is x, and I can easily solve for it now. So let's go ahead and let's actually substitute the value of mu. If you remember, mu from before was 0.45 right here. Okay, so let's put that in as well. And the value for ml and mp, the mass of the ladder was, I think, 10 kilos, and mp was 66 kilos from here. Okay? So let's all work it in and see what we get. Solving, now I'm solving for x. Okay, here we go. So it's 0.45 multiplied by 10 plus 66. I'm going to leave the units off just for now so that I can fit it on the screen here. Minus 10 times 9.8 times 3.5 over 2 minus, now not minus actually. This is now going to equal x, but if we take this term over to that side of the equal sign, here's the equal sign, it's going to become positive, but we still have to divide by mpg. So we're going to divide this whole thing by mp, which is 66 times g. Now let's get out our trusty RPN calculator and see what we get for this value. So we're going to go 0.45, enter, 10, enter, 66 plus, that was easy, 76, times, 9.8 times, 5 times, and then 10, enter, 9.8 times, 3.5 times, oops, I messed up. I didn't do 0.5 times. I went 3 times. Drats. Hold on. Let's go 3 divided by. Okay, 3.5 times 2 divided by minus, and now 66 divided by and 9.8 divided by. And I'm getting an answer of 2.3258, or basically 3.26. Okay. Let's just make sure that's correct, but I think it should be. Okay, so what do we do now? Are we done? Well, we got x, but what's the question asking for? Well, the question's asking for how high up does this person get to go? Well, we now have this distance. Getting this distance is now trivial, okay? And the reason is because that we know this angle. This angle is basically 5 over 3.5, and that's easy to get, right? Here, let's do it up here so maybe I can fit it in here so you could see. If you consider this angle theta as SOHCAHTOA, tan theta is equal to 5 over 3.5. Therefore, theta is equal to the inverse tangent of 5 over 3.5. Therefore, theta is going to equal 5 enter 3.5 divided by inverse tangent 55 degrees. And hence, now that we know this angle and we know this side, we should be able to get this, because we know that tan 55 is going to equal the height h divided by the horizontal distance of what we calculated earlier being 2.326, I think it was, right? Wow, it's all the way down here. Yeah, there it is. 2.326. 2.326. And I think that's what I wrote. 2.326. So h, therefore, is going to be 2.326 times tan 55. 2.326 times. Answer, h turns out to be 3.3 meters from the ground. So that's this distance here. Okay? So that's the maximum height. Getting the distance that the person travels along the ladder, I think, is pretty trivial also. It just ends up using, you can use Pythagoras to get that. But I think the question is asking for the height off the ground the person can go. And if he goes any further than that, the ladder is going to slip. So once again, there is the whole solution. I just want to make sure that I got this answer right. If I go 0.45, enter 76 times 9.8 times 5 times, and then I go 10, enter 9.8 times 3.5 times 2 divided by minus 66 divided by 9.8 divided by. Yes, I did get that correct. Okay, hope you enjoyed that problem. See you next time.